Welcome. This is demo for data mining course project, biodata visualization. Okay, I'm gonna start the software right now. This is a mainframe for the software. You can see from here that on your top navigation bar, there are two buttons. One is open data, another one is data reduction. Since right now there is no data already imported, so data reduction button is disabled. And on your left hand side, here is navigation tree. After we import data, you will see that the tree will be grown. Because right now we have nothing, so the function you can trigger is only software information. Let's look to it. As you see that this software is mainly developed by Kevin Liu, Yating Wen, and Yang Chen. As you know that visualization, first of all, we need data set. So first we import data. Ideally, there will be several data sets available right here. You just choose the data set you want to import it. However, right now we only have colon data, which is colon cancer data. Okay, and it also the training data for our model building. We will import it now. After import this data set, we see the navigation tree has already been grown up. When you click it, you will see the function you can trigger is raw data of colonCA. We click it and see the raw data. Probably you have to wait a moment right here because it takes a little bit time. Okay, here is our raw data. There are totally 62 rows and 2,000 columns because this data have 62 samples and 2,000 gene attributes. And also from the description you can see that there are 40 samples from tumors and be labeled as negative and 22 samples labeled as positive. Okay. Such a huge data set is impossible to be visualized in no matter 3D visualization or 2D visualization. So first of all, we have to do is data reduction. We include 3 data reduction algorithms inside. They are PCA, LLE, and Isomap. You can just choose the data reduction algorithm you like, and here is dimensions. That means how many attributes will be selected inside. I have to indicate right here that all the dimensions you choose, for example 2, that means the top 2 most significant attributes for the sample expression. So we just simply choose PCA, which is a very traditional data reduction algorithm. And after it, you will see here PCA dimension 2. Then their corresponding functions is already been triggered. Okay, we choose another one. We choose Isomap. We choose 4. And K nearest neighbors is 5. Okay. Then the tree grown up again. You will see Isomap functions available here. And I have to indicate right here again that we imported 4 toughest most significant attributes. That means you can also make combination of 2 attributes and 3 attributes. However, in this PCA right now we only have 2 attributes. We think it's probably not so convenient for our description for the demo. So we will import another one also under PCA and dimension is 4. Okay. Then you will see the tree grown up. Here is Isomap dimension 4 and here is PCA dimension 4. We'll basically show these 2 categories. And from here we have 4 visualization tools. there are cluster, motion, 2D visualization, 3D visualization, and 4D visualization. The order I'm gonna show you is 4D visualization, 2D visualization, 3D visualization, and finally cluster motion. First of all, we look at 4D visualization. This one is under Isomap, and this one is under PCA. The basic function for 4D visualization is RGB function in Java. As we know that for RGB, when you include 3 vectors between 0 to 255, it indicates the value for corresponding color, that is red, green, and black under the RGB. When you include the 4th vector, that means the opacity of that color. So that is the mainly function we used right here. From these 2 visualization results, you may notice that we also have red frames and green frames. Red frames indicate that this sample is a sample with tumor, and green frame means a sample without tumor, which is healthy. It's probably not so easy for us to notice to do classification of healthy sample and unhealthy sample. So okay, maybe in this result we may notice that for healthy sample their color always go to black. However, for unhealthy their color varies. Probably this is a conclusion for it, but we are not sure. And because we didn't use any color analysis right here, so we cannot give further conclusion here. And then I am gonna introduce for 2D visualization. As we see that in 4D visualization, even though we included many attributes, but the result is not so obvious. So we want to see less attributes and see the result, which should be clearer. We trigger it, and also 2D. Because we already have 4 attributes, we can make combination of them. When we choose 2 out of 4, then we will get 6 combinations. Let's trigger any of them. Okay, and here. We just choose 2, and I think this one is coming from PCA data reduction, and this one is coming from Isomap. From these 2, that it's more clear of samples representation. Here, that green color represents the healthy sample, and red color represents unhealthy samples. We scatter all the samples in this field that X and Y value, the maximum value is corresponding to the maximum value within all the all the samples X or Y